All right, so today we are going to be talking about how to simplify, multiply, and divide rational expressions. Now, in order to do that, we're going to need to be able to factor pretty well. So we want to start by reviewing some factoring and making sure that we're comfortable with that. So we're going to factor each expression. So for number one, I see that I have a trinomial that begins with x squared. Therefore, when I factor it, I know I'm going to have two parentheses that both begin with x. Now to figure out the numbers that need to go in there, I'm looking for two numbers that multiply to give me 12 and then add to give me 7. So then multiply to give me 12, I only have a few options. 1 times 12, 2 times 6, and 3 times 4. So I can always go over here and I can make a table for that if I'm not sure what it's going to be. So 1 times 12, 2 times 6, and 3 times 4. Now I have to pay close attention to my signs. Since they need to multiply to give me a positive 12, that means my signs have to be the same, either both positive or both negative. And then, since they're going to have to add to give me a positive, that means that they must both be positive. So then I'm looking for two numbers that are going to add to give me 7, which would be those right there. So positive 3 and positive 4. So my factors are going to be x plus 3 and x plus 4. So that's factored. Now in number 2, I have another trinomial that begins with x squared. So again, I know I'm going to have two parentheses. Both are going to begin with x. And I'm again looking for two numbers that multiply to give me 12. So I can still use the same table I did in number 1. But this time, they're going to need to add together to give me a negative 8. So since I have a positive 12 that these numbers need to multiply to be, that means I need those numbers to have the same sign again. But this time, they're going to both need to be negative because they're adding together to give me a negative number. So if I look up here, which two numbers are going to add to give me 8? Well, 2 and 6. However, in this case, I'm going to need them to both be negative. So that's going to be negative 2 and negative 6. So my factors will be x minus 2 and x minus 6. All right, so that one's done. Now for number 3, again, trinomial that begins with x squared. So we're going to have two factors that begin with x. And again, I'm looking for two numbers that multiply to give me 12, but this time they're multiplying to give me a negative 12, which means I need opposite signs. So one of them has to be positive, one of them has to be negative. That's the only way for them to multiply to give me a negative number. And then the number that they need to combine to give us in the middle is going to be a positive 1. Remember that x has an understood 1 in front of it. Now, if those signs are going to be opposite, then I'm not actually adding those numbers. I'm now subtracting them. So I want to go back up to this table for 12 and look for two numbers that are going to subtract to give me 1. And that's 3 and 4. So I know I want to use 3 and 4, but the question is which one has to be positive and which one has to be negative. So remember, I need them to combine to give me a positive 1. Therefore, the bigger number is going to have to be positive. So I'm going to have a positive 4 and a negative 3. Now double check yourself. So positive 4 times negative 3 does give me a negative 12. That's good. And then positive 4 plus negative 3 would give me a positive 1. That's good as well. All right, so we have our signs correct, and we're done. All right, for our next one, number 4, another trinomial that begins with x squared. And we're still looking for two numbers that are multiplying to give me 12. And it is a negative 12, so again, I know I need opposite signs. One is going to have to be positive, one is going to have to be negative, which means they're subtracting. But this time, I need them to subtract to give me 4. So we're going to go back up here, and we're going to look for two numbers that subtract to give us 4. Well, 2 and 6 would subtract to give us 4. But we need to be, again, careful with our signs. Since I'm going to use 2 and 6, but they're going to subtract to give me a negative 4, that means the bigger number needs to be negative. So that means the 2 is going to be positive and the 6 is going to be negative. All right, so we're done with 12. Let's move on to something else. So we have another trinomial, begins with x squared. So again, two parentheses. Both of them begin with x, but this time I'm looking for two numbers that multiply to give me positive 16. That means my signs have to be the same, either both positive or both negative, and they're going to combine to give me that negative 8 in the middle. So since they're going to combine to give me a negative, that means that they're going to both need to be negative. But negative what? So what numbers multiply to give me 16 and combine to give me 8? Well, 4 and 4. So we're going to have negative 4 and negative 4. Now normally when we did factoring, I would have had you write this as x minus 4 squared. But we're actually not going to do that today, because with what we're going to do, it's going to be more beneficial for us to leave those separated side by side. So I want you to leave it like this for today. All right, number 6. Now, I don't have a trinomial anymore. I have a binomial, only two terms. But if I look at this, I notice that both the first term and the second term are perfect squares, and it's subtraction. That tells me that this is a difference of squares. Therefore, I'm going to have two parentheses, still going to begin with x because I have x squared. However, since it's a difference of squares, I know I'm going to have 1 plus, 1 minus, and then I need to know what multiplied by itself gives me 16. Well, that's 4. So we're going to have 4 and 4, x plus 4, x minus 4. So we talked about before, x squared is x times x, so that's where those come from. And then 16 is 4 times 4. We have to make sure, since it's a difference of squares, that we have our opposite signs because there is no x term in the middle. All right, number 7. Now this looks an awful lot like number 6, but not exactly. We have this x here, which means that is not a perfect square because there's nothing times itself that gives me just plain x. So I'm not going to treat this like a difference of squares, but I do notice, however, that both of those terms have something in common. They both have some form of x. Therefore, I'm going to be able to factor out some form of x. Now, the first term is two x's multiplied together. The second term only has a single x. Therefore, I can only factor out a single x. Now, remember, when we take out a greatest common factor, what goes in the parentheses is what's left after you divide both of those by the greatest common factor. So your greatest common factor has to sit in front, and then you open your parentheses, and then inside you're going to put what you get after you divide. So x squared divided by our greatest common factor, which is x, would be just x. The second term divided by x would give me negative 16. And then that's actually done, because even though this is a perfect square, this is not. Therefore, it is not a difference of squares, and I cannot factor it anymore. So it is done the way it is. Now for number 8, I see that I also have a greatest common factor in this one. But this time, yes, it does have x in common, but that's not the only thing it has in common. So we do know that our greatest common factor is going to contain x, but I notice that both of these numbers are divisible by 4. So my greatest common factor is not just x, but 4x. Then open my parentheses, and the first term divided by 4x, well, 4 divided by 4 would be 1, and then x squared divided by x is x. So that would be 1x, or we just put x. Then the second term divided by 4x, well, negative 16 divided by 4 is negative 4. And then x divided by x is 1. So really those x's just cancel. So we have 4x times x minus 4. And again, even though this is a perfect square, this is not. So it is not a difference of squares, and we will not factor that anymore. It's done the way it is. So that's a quick review of factoring. Anytime you're factoring, always keep an eye out for greatest common factor. Sometimes it's really easy to forget that, but always kind of be looking for a greatest common factor. So we're going to take all this factoring, and we are going to talk about how to simplify, multiply, and divide rational functions. Now, we talked about before that rational functions are really just fancy fractions that have x in the denominator. So we're going to be multiplying fractions. Now, for our rational expressions, we need to first realize, so we're going to take a look at this, and we're going to talk about simplifying real quick. Simplifying is the easiest. Now, it says, let a, b, and c be non-zero real numbers or variable expressions. So we're not just talking about a, b, and c. We're saying that those stand for something. So we have whatever a is times whatever c is over whatever b is times whatever c is. All right, so those have to be non-zeros. So the following property will apply. Well, if we notice, we've got the same thing on top and bottom. We have c on top and bottom. When that's the case, whether those are numbers, variables, or entire factors, if we have the exact same thing on top and bottom, then those factors divide out to equal 1, because anything divided by itself is 1. So these together become just 1, which means they really kind of just go away. And all we're left with is the A and the B, whatever those may be. So that's the basic principle of simplifying. Now we want to apply that to something that has a little bit more to it. So we're going to simplify the following rational expressions, and we're going to state any restrictions on the domain. So the restrictions on the domain are any number that will make the denominator equal to 0. So that's the key. The denominator cannot be 0. The numerator can, that's fine. The denominator cannot equal 0. So if I'm looking at this function, so that's the first thing I'm going to do is determine my restrictions. So I'm just going to put R for restrictions. So if I'm looking at just the denominator, well, remember that this is -6 times x squared times y cubed. And when we're talking about multiplying, then if any single one of those things equals 0, then the whole thing equals 0, because anything times 0 is 0. So this can't equal 0. That's not possible, so I don't even worry about it. However, if x was 0, then 0 squared is 0, and 0 times anything else would be 0. So if x is 0, that would make our fraction undefined. So x cannot equal 0. And then the same thing for the y. If y was 0, then that whole denominator would equal 0. So y cannot equal 0 either. So those are our restrictions. Now, we want to talk about how to simplify this now that we know what our restrictions are. All right. Now, when we have a fraction like this, we want to pay attention to how many terms are there. And so in the numerator of this fraction, we have one single term. Those are not multiple terms because terms are separated by pluses and minuses. There are no pluses or minuses in here. Therefore, that is one single term. Same thing on the bottom. I have a negative in front, but there's nothing being added or subtracted. So that's one single term. So when that happens, when we have one single term on top and one single term on the bottom, then we're going to look at just simplifying each piece of this fraction. So we're going to start with just the numbers. So if I'm looking at 24 divided by -6, and I'm going to go ahead and write my fraction because I don't know for sure where I'm going to need what. So 24 and -6 can both be divided by -6, or think of it as 24 divided by -6. Well, that's going to give us a -4. So we're going to put that -4 on the top. Then we're going to look at our x's. That's the next piece. So we have the x's. Well, I have x cubed on the top and x squared on the bottom. And we need to remember what that means. So x cubed means that there are 3 x's multiplied together. X squared on the bottom means that there are 2 x's multiplied together on the bottom. Now, since I have x's on top and bottom, I know that those can cancel in pairs. So I'm going to have one of these x's cancel with one of these. I'm going to have one of these x's cancel with one of these because x divided by x is 1. And then this x has nothing to cancel with. Therefore, that's still there. And I'm going to put that one remaining x on the top because that's where the one remaining x is. And then I'm going to do a similar process for my y's. So on the top, we have y squared, which is y times y. On the bottom, we have y cubed, which is y times y times y, 3 y's. So then I have y divided by y gives me 1. Those are gone. Then y divided by y gives me 1. Those are gone. So I have a single y left on the bottom. Therefore, I want to put that single y that's left on the bottom of my fraction. And so then I have simplified all the pieces of that fraction. Therefore, I have my answer. And I want to include my restrictions as part of my answer. So that would be my fraction simplified, but I have to understand that x can't be 0 and y can't be 0. They can be anything else, just not zeros. All right, so let's take a look then at number 2. Now for number 2, I do have more than one term in the numerator and denominator of the fraction. So when that happens, I can't just start simplifying things. I can't say, oh, hey, I have x squared and x squared. Those divide out to give me 1. It doesn't work that way. So when I have more than one term on the top or more than one term on the bottom, I have to factor. So then I'm going to take that numerator, and I see that I have a trinomial that begins with x squared. So just like in our warm-up, we know we're going to have two factors that both begin with x. Now we are looking for two numbers that multiply to give us 10, positive 10, so that means my signs have to be the same. And since they're going to add together to give me a positive 7, that means they need to both be positive. Now, what two numbers multiply to give me 10 and add to give me that positive 7? Well, that's going to be 2 and 5. So positive 2, positive 5. So double check. Positive 2 times positive 5 is positive 10. Great. Then positive 2 times positive or plus positive 5 is a positive 7. So perfect. We're good to go. So the numerator is factored. Now we need to look at the denominator. The denominator is also a trinomial that begins with x squared. So we're going to have two more factors in the denominator. Both begin with x. But this time I'm looking for two numbers that multiply to give me a negative 10, which means my signs have to be opposite. So one has to be plus, one has to be minus. If those signs are opposite, then they're actually going to be subtracting to give me that negative 3. So 2 and 5 will also do that. However, watch your signs. So if I'm going to use 2 and 5, since when I add them together, they need to be a negative 3, that means the bigger number has to be negative. So the 5 has to be the negative, and the 2 then would have to be the positive. So once we have it factored, then just like in this example up here, I'm looking for what do I have that's the same and can divide out to be 1. So remember, we said we had these c's. C divided by c is 1. So that basically made them go away, and then what was left was our answer, our A and our B. So over here, what do we have that's exactly the same? Well, we have an x plus 2 in the numerator. We have an x plus 2 in the denominator, which means if I do x plus 2 divided by x plus 2, that's going to give me just 1. So basically, those factors completely go away. And what we're left with is the x plus 5 in the top, and in the bottom we have x minus 5. And then since I only have a single factor on the top and the bottom, then those parentheses aren't really needed. If it makes you feel better, you can keep them. There's nothing wrong with that, but they're not needed since there's nothing to separate them from. And so that would be our answer. Now, we didn't even talk about restrictions, so let's look at this problem. So for our restrictions, I want to look at the factored form. So once I got it factored here, I want to look at my denominator. So my first factor of x plus 2, well, the only thing that would make that factor equal 0, so set it equal to 0, would be if x was negative 2. So that tells me that x cannot equal negative 2. Then I take the other factor from the denominator, which is x minus 5. I need to know what would make that equal 0, because we can't have that. And so that would be if x was positive 5. So if x was positive 5, then this factor would equal 0. So that tells me that x cannot equal positive 5. So then I want to include that in my answer. All right. Now, let's talk about multiplying. Now, we know in general, when we multiply fractions, that we're going to take those fractions and we're simply going to multiply the numerators together, which would give me a times c, so whatever a is times whatever c is. And then the denominators would also get multiplied together, so I would take whatever b is and multiply it by whatever d is. So that's in general how we work with multiplying fractions. Now, we have to remember, though, that our fractions cannot have 0 in the denominator, which is why it says here that b cannot equal 0 and d cannot equal 0, because that's what was in our original denominator. Now, if we're talking about dividing fractions, we've got a little bit extra to do there. So when we divide fractions, well, first of all, when we learned how to deal with fractions, we never actually divided fractions. What we did is we multiplied by the reciprocal, or most of us learned the phrase keep, change, flip. So, keep, change, and, and flip. So the keep means keep the first fraction. So a over b, we're going to keep the same. Change means I'm going to change this division to multiplication. And then flip means we are going to flip the second fraction over. So instead of c over d, it's going to be d over c. And then we just apply the multiplication. So we would multiply the numerators together, which would simply give me a times d. And then we would multiply the denominators together, which would give me b times c. Now for this one with the restrictions, notice that this one says that b, c, and d cannot equal 0. And here's why. Well, b and c make sense because, well, can't have 0 there, can't have 0 there. But in your original problem, you had d in the bottom of the fraction. So that's why you can't have any of those three equal 0. A is the only one that is never on the bottom of a fraction, so it would be okay for a to equal 0, but not the others. So anything that is ever in the bottom of a fraction cannot equal 0, and it's going to give us one of our restrictions. So let's take a look first at a nice simple one. So for this first example, we only have one term in the numerator and denominator of each of those fractions. So that means I don't have to worry about any kind of factoring. So I could go ahead and multiply straight across, but then I'm going to get 3 times 49. That's going to be kind of a big number. And then here, I'm going to get 35 times 12. That's going to be a big number too. So that seems like that's hard. So what I want to do is I want to try to simplify before I multiply and make my life a little bit easier. Now, when we talked about simplifying up here, we said that we could simplify the top and the bottom. That is also true when we have more than one fraction. So anything on the top of either of those fractions can simplify with anything on the bottom in either of those fractions. As long as one's on top and one's on bottom, we can simplify them. So the first thing I see is that I have a y on both top and bottom, which means y divided by y is 1. So really, those y's just kind of go away. Now, I can't do anything about the x and the z though, because those are different. So they're not going to divide out and give us 1. So now let's start looking at our numbers, because that's where we're really trying to fix, is to not have those big old numbers. So I want to look at those numbers and see, are either of those numbers on top able to be simplified with either of the numbers on the bottom? And our answer is yes. So 3 and 12 can both be divided by 3. So I want to go ahead and divide each of those by 3, and I'm going to get a new number. So 3 divided by 3 is simply 1, and then 12 divided by 3 is 4. So I have simplified those numbers. The old numbers are gone and replaced by those new smaller numbers. Then I see that 49 and 35 can also be divided by the same thing. They can both be divided by 7. So 49 divided by 7 is 7, and then 35 divided by 7 is 5. All right, so I have simplified everything I can. And so this kind of looks like a big jumbled mess. So we want to be very careful that we don't miss what's left. So what we have left is 1, and then we have this x that's kind of hiding, and then we have 7. So if I multiply all of those together, well, first of all, 1 times 7 is going to give me 7. All right, so I know I have 7, and then I also have my x. So then that's going to give me 7x. Great. Now on the bottom in the denominator, I have 5, I have 4, and I have z. So if I multiply all of those together, then 5 times 4 is 20, times z would be 20z. And so then that is my final answer. Now my restrictions, however. So if I want to look at my restrictions, then I want to go back to this original, because I've got marks all over the place. So I'm going to erase all of this stuff so we can look at our original problem. All right, so what did we have in the bottom? Well, I'm not worried about the numbers because the numbers are automatically not 0. I want to look at my variables. So my first variable in the denominator is y. Well, if y was 0, then this entire denominator would equal 0, and we can't have that. So y cannot equal 0. Then in the second fraction, I have a z in the denominator. If that z was 0, then this entire denominator would equal 0, and we can't have that happen. So that tells me that z also cannot equal 0. And so then those are going to be our restrictions. Alrighty, so now let's take a look at some problems that have more than one term in them. So if we have more than one term in any piece of any fraction, then we're going to have to factor. So we want to look at each piece, each denominator, each numerator of each fraction, and decide if it can be factored. So if I take a look at this first numerator, x minus 2 cannot be factored. So we're not going to mess with that at all. We're going to leave it alone. 5x really can't be factored. I could, if I wanted to, write it as 5 times x. Don't really need to, but I can. I want to realize in my head that that's the case. That's what it means. But I don't really have to write that. I can, though. Same thing here with 10x. That doesn't really factor. If I want to, I can write it as 10 times x. That's fine. It's the same thing. But this piece down here does factor. So remember we said to always be on the lookout for a greatest common factor. And this one does have a greatest common factor. Both of those terms can be divided by 3. So if we take that 3 out, then what goes in the parentheses is going to be what's left after we divide each term by 3. So if I take 3x squared and I divide it by 3, that's going to give me just x squared. So that's the first term in our parentheses. Then if I take this negative 12 and I divide it by 3, then that's going to give me negative 4. So then I have that minus 4. But when I do that, I see, oh wait, this is a perfect square, this is a perfect square, therefore this is a difference of squares, and it can be factored more. So I'm going to have that 3 in front still, but then x squared minus 4 can be factored some more, and that's going to give me x plus 2 and x minus 2. because positive 2 times negative 2 gives me this negative 4. And then positive 2 plus negative 2 gives me 0, which is why there is no x term in the middle. All right, so now that we have everything factored, let's rewrite this and start looking at what can simplify. So that x minus 2 didn't change at all. Then 5x, we could write it as 5 times x. Don't have to, but we can. Then our second fraction was 10x, which we could leave that way or write it as 10 times x. And then the one we could actually factor was 3, don't forget your greatest common factor sitting in front, times x plus 2 times x minus 2. So that's the factored form of all of our fractions. Now we want to look for common things that we can cancel out or divide out to get 1. So I see that I have an x plus 2 on top. I have an x minus 2. X minus 2 on top and x minus 2 on bottom, which means those divided out would give me 1, so they're gone. I also see that I have an x on the top and an x on the bottom, so those divided out would give me 1, which means they're gone. Now those are the only things that will straight up cancel. However, I have a 10 and a 5 that will simplify. They don't divide each other out, but they will simplify. They can both be divided by 5. So that 10 divided by 5 gives me 2, and then my 5 divided by 5 gives me 1. So now, my answer, once I'm done simplifying everything, is going to be whatever is left over. So in the numerator, the only thing I have left is that 2. That's it. So that means my numerator is just going to be 2. Now, in the denominator, though, what I have left is 1, I have 3, and I have x plus 2. Well, 1 times 3 is simply going to be 3, but then I have that x plus 2 as well. So that is my simplified product of these original two fractions. Now again, we need to do our restrictions. So for the restrictions, we're going to go back to the factored form. So for our factored form, for this first one, the only variable I have in the denominator is x. So this x is being multiplied by 5. So if x was 0, that would make this whole denominator equal 0. So x cannot equal 0. And then if I look at my second fraction, well, I don't need to worry about the 3 because 3 can never equal 0. But I do need to worry about this factor equaling 0 or this factor equaling 0. So in order to get this factor to equal 0, x would have to equal -2. So that means x cannot equal -2. So far we have 0 and -2 that x can't be. If we take a look at this last factor, the only thing that would make that factor equal 0 is a +2. So that means x cannot equal +2 either. So we have our 3 values here that x cannot be. Those are our restrictions. And so then this entire thing would be my answer. I have my restrictions and my simplified answer. All right, let's take a look at number 3. And I'm going to erase a little bit of this so it does not get jumbled with my next problem. Okay. So for example 3, we've got to start factoring because we have multiple terms everywhere. So let's start with this first numerator here. It is a trinomial that begins with x squared. So I know that I'm looking at 2 parentheses that both begin with x. Now, I need 2 numbers that multiply to give me -6. That means opposite signs. Therefore, they're going to need to subtract to give me a +1. So that's going to be 3 and 2. Now, the 3 will have to be positive and the 2 will have to be negative, because if I have those reversed, then they would combine to give me -1, not +1. And I need it to be a +1. All right, so that's done. So our first fraction, factored out, is x plus 3 and x minus 2. Now we still need to look at the denominator, and I'm actually going to move that down a little bit further. Okay, so let's look at the denominator of that fraction right there. Well, that's x minus 5. There is no greatest common factor, and it's only x, not x squared, which means I can't factor that one. So I'm going to leave it just the way it is and put it back in that denominator. Now let's take a look at our second fraction. So if I take a look at the numerator, well, that's another difference of squares, because x squared is x times x, and 25 is 5 times 5. Therefore, those factors are going to be x plus 5 and x minus 5. All right, now we need to look at this last piece, the denominator of the second fraction. So it's a trinomial that begins with x squared. Therefore, I know that I am looking at two parentheses that both begin with x. But this time, my numbers need to multiply to give me a +3. That means my signs must be the same, and that same sign must be positive. So I'm looking for two positive numbers that multiply to give me 3 and combine to give me 4. So that's going to be a +1 and a +3. All right, so we're going to put that factored form in the denominator of that second fraction. All right, so there we have everything all factored out. Now, before we start canceling everything and making it look all messy, let's go ahead and do our restrictions right now. So for the restrictions, we are only worried about the denominator. So for this denominator to equal 0, the only thing that would make that equal 0 is if x was 5, because 5 minus 5 would be 0. So I know right there that x cannot equal 0. All right, let's go to the second fraction. For that factor to equal 0, x would have to be -1. So x cannot equal -1 either. For this factor to equal 0, x would have to be -3, because -3 plus 3 is 0. So that means x also cannot equal -3. So these are our restrictions. So now that that's out of the way, let's take a look at this factored form and see what things can we cancel out. So we're looking for anything that's identical on top and bottom. It doesn't matter if they're in the same fraction or not. So the first thing I see that's the same is I have an x minus 5 on the top and the bottom. So I have an x minus 5 here, I have an x minus 5 here. So as long as one's on the top and one's on the bottom, they can cancel out. So those are gone because they divide out to give us 1. Then I also see that I have an x plus 3 on the top and the bottom, which means they would divide out to give us 1, so they're basically gone. Now those are the only things I see that cancel out, and there's no numbers to simplify, therefore whatever is left is my answer. So in the numerator, I have the x minus 2 left in the first fraction, and I have an x plus 5 left over in the second fraction. So that's my numerator. In the denominator, the only thing I have left out of either of my denominators is that x plus 1. And so then that's my answer, all simplified out. So I have my restrictions and my simplified answer. So really, if we can factor, then we can do this. The factoring is really the tricky part, and we have to be careful. Always make sure that you're looking for a greatest common factor. Now we have a couple more problems to do, and I need to be very careful because these are division. And as soon as I see a division symbol, then I need to be thinking keep, change, flip before I do anything. So as soon as I see this division, I know I need to keep the first fraction the same. I need to change the division to multiplication, and I need to flip the second fraction. So we're going to do that before we even start trying to factor. So I'm going to keep the 7x plus 14 over x minus 1. Then I'm going to change the division to multiplication, and then I'm going to flip the second fraction. So the 5x squared minus 5 now goes on the top, and then the 7x squared minus 28 now goes on the bottom. So once we have that changed, notice we now have a multiplication problem, which means it's going to work exactly the same as what we just did in those last couple of problems. So we're going to factor everything that can be factored, and then we're going to start looking for what will cancel, and then whatever's left over is our answer. So let's look at the numerator in this first fraction. 7x plus 14. So it's not x squared, so we're not going to factor in the traditional sense. However, I do notice that both of those terms can be divided by 7. So I want to take the 7 out, put it in front, open a parentheses, and then determine what I get when I divide each term by 7. So 7x divided by 7 would just be x. Then 14 divided by 7 would be a positive 2. So plus 2. All right, the numerator's done. Now the denominator of that fraction is x minus 1. That can't be factored. So we're just going to bring it down the way it is. Then we have our multiplication. And now we're going to look at the numerator for our second fraction. So it is x squared, so there is a possibility of doing actual factoring, but I have to notice first that there is a greatest common factor. Both of those terms can be divided by 5, so I need to do that first. So I'm going to factor out my 5, and then 5x squared divided by 5 would give me x squared. Then negative 5 divided by 5 would give me a negative 1. Okay, well notice in this parentheses now is a difference of squares, which means that can be factored, and I'm going to get almost identical factors, but the signs are going to be different. Now, I can't lose this 5. It still has to sit in front. But then that x squared minus 1 is now going to factor to give us x plus 1 and x minus 1. So always be on the lookout for greatest common factor, and always be on the lookout for the difference of squares as well. All right, so that gets that piece completely factored. Now I need to look at this one, and it's actually going to do something very similar. So I have x squared, so I know that there is the potential that I'm going to have to do that 2 parentheses thing. But before I do that, I notice that 7 and 28 can both be divided by 7. So I want to do that first. I want to take that 7 out, and then if I divide each term by 7, that gives me x squared minus 4, which, what do you know, is another difference of squares. So make sure that you keep that 7 in the front, but then that x squared minus 4 will factor to be x plus 2 and x minus 2. All right, once everything is factored, now I just want to look and see what can I cancel, what can I simplify. So I see that there is an x plus 2 on the top and the bottom, which means those are gone. They divide out to be 1. Then I also see that I have an x minus 1 and an x minus 1, top and bottom. So then, actually, we're going to back up and get our restrictions before I get this all messy. So everything's factored, so our restrictions, So look at each denominator. So for this factor, what would make it equal 0? Positive 1. So that tells me that x cannot equal positive 1. Then 7 can't equal 0. Don't worry about that. The next factor, what would make that equal 0? Negative 2, because negative 2 plus 2 would be 0. So x cannot equal negative 2. Then our last factor, what would make that equal 0? Positive 2, because positive 2 minus 2 would equal 0. So x cannot equal positive 2 either. So there's our restrictions. Now, let's go back to getting all of these factors canceled out. So we said that we had x plus 2, top and bottom. Those cancel. We have x minus 1 on top and bottom. So those cancel. And then those are the only factors that are the same. However, I do have a 7 on top and bottom that not only will simplify, but they're identical. So they completely simplify each other out. 7 divided by 7 is 1, so they're gone. So the only thing that I actually have left is I've got the 5 on top. I have an x plus 1 on top. So that gives me my numerator for my answer. 5 times x plus 1. Now for the denominator, the only thing I have left is this x minus 2. So that goes in the denominator of my answer. And since it's the only factor that's left, I don't have to have parentheses there, but I can if it makes me feel better. So I have my restrictions and my simplified answer. All right, we have one more problem to do because even though we have a word problem down here, it's not a very good word problem. So we're going to skip it. So we're going to stop after we get done with number 5. Okay, so first thing I see, it's division, which means I need to keep, change, flip. And let me erase this so it doesn't get jumbled up. All right, so keep, change, flip. We're going to keep the first fraction exactly as it is, x squared plus 5x minus 24 over x squared plus 9x plus 8. So that's our keep. Then we need to change the division to multiplication, and then we need to flip the second fraction. So 6x minus 18 will now go on top, and then x squared minus 9 will now go on the bottom. And now we need to factor each of these. So take the first numerator. It's a trinomial that begins with x squared. Therefore, that's going to give us 2 parentheses that both begin with x. Now for that one, we're looking for 2 numbers that multiply to give me a negative 24. That means opposite signs, one positive, one negative, which means those numbers are actually going to subtract to give me 5. So think about what we can multiply to get 24. So we could do 1 times 24. We could do 2 times 12, 3 times 8, or 4 times 6. Those are our options. So which one is going to subtract to give us 5? That one, 3 and 8. Now make sure that you get your signs correct. So they need to subtract to give me a positive 5, which means the bigger number has to be positive. Therefore, I want plus 8 and minus 3. All right, so there's our first bit factored. Now let's take a look at the denominator of that fraction. Again, we're going to have 2 parentheses that begin with x. But now we are looking for 2 numbers that multiply. Let's do another color. They multiply to give us 8, positive 8, which means the signs have to be the same. And since they're going to add to give us a positive 9, that means those same signs must be positive. So what multiplies to 8 and adds to give us 9? 1 and 8. All right, that one's done. So we're going to keep our multiplication symbol, and then look at this next piece. Well, there's no x squared, but I do have a greatest common factor. Both of those terms can be divided by 6. So I'm going to put that 6 in front, open up my parentheses, and then each of those terms divided by 6 will be what goes in the parentheses. So 6x divided by 6 would just be x, and then negative 18 divided by 6 would be negative 3. All right, that takes care of that. And then our last piece that we need to factor is a difference of squares. So x squared minus 9 will factor to be x plus 3 and x minus 3, because x squared is x times x, and 9 is 3 times 3. A difference of squares is almost identical parentheses except for one is plus and one is minus. So now we have everything all factored out. So this is where we want to figure out our restrictions. Then we'll start canceling things. So for our restrictions, look at each factor in the denominator. Remember, numerator doesn't matter for restrictions, just the denominator. So my first factor in the denominator is x plus 1. So the only thing that would make that parentheses come out to be 0 is a negative 1, because negative 1 plus 1 is 0. So x cannot equal negative 1. Then here, x cannot equal negative 8, because that would make that parentheses equal 0. Then our next factor, x cannot equal negative 3. And then our last factor, x cannot equal positive 3. So notice that your restrictions always just have the opposite sign of your factor. So that makes it a little bit easier. All right, so we have our restrictions. Now let's see what we can cancel and get our final answer. So what do we have in common between the top and the bottom? Well, I see x plus 8 in both the top and the bottom. Therefore, gone. I also see that I have an x minus 3 in the top and the bottom. Ooh, I actually have two x minus 3's on the top. But this x minus 3 on the bottom will only cancel with one of these x minus 3's, not both. So it doesn't matter which one you cancel as long as you only cancel one of them. So I'm just going to go ahead and stick with this one. So those are gone. Now I still have the other x minus 3 on top, and that's okay. Then if I look, I don't see anything else that's in common between the top and bottom. I don't have any numbers on the bottom that I could try to simplify with that 6. So that means I'm done simplifying. I'm just going to write down whatever's left. So on the top, the only thing that's left is the 6 and the x minus 3. On the bottom, the only thing that's left is an x plus 1 and an x plus 3. And so then that would be my answer, along with the restrictions on x. All right, so that is how we simplify, multiply, and divide fractions. So it's a very similar process for all three. Basically, you're going to factor and cancel, with the exception that when you see a division, you must, before anything else, keep, change, flip. Then you'll do it just like all the other problems. Also remember that if you have any problems that only have a single term, like these, then you're not trying to factor, you're just trying to simplify. All right, so that is it for today, and then I will see you guys next